session's being recorded. Just keep in mind that anything you say or type will be forever recorded with your name connected to it. So please be mindful of the audience and conduct yourself in a professional and respectful manner. All right, so how do you create a finished ground surface? So now that you have all your design points, right? So the front lot corner, the rear lot corner proposed, and anything in between. Once you have all your design elevations for FG, to create a finished ground surface, you right click, create a surface. Give it a name. I'm going to call mine FG. I'm going to call it 2 because I already have one, but it should just be called 1 or FG by itself. And I'll leave it as the standard style for now. And then what you want to do is to that surface, oops, let me just stretch this down here, to that surface FG, you want to add a point group called FG, and it should produce the surface. Now, if the surface doesn't appear, it's because maybe that the group, the point group FG is empty. If this is empty and you're using this group to build your surface, for instance, if I change my match to include, right? If I change this to, if I change it to finished, right? Fin ground, that's not, there's no point. See that dot's missing, that black dot? So when I update the group, it's empty. And then when I update the surface, it's empty, so it doesn't build anything, right? So you have to make sure the group is not empty. So that might be one of the problems that comes up. So if you don't have the proper include here, if the points aren't in the group, they won't be in the surface, right? So you got to be careful about that. Okay, so that translates directly. If you, I'm going to use the group called FG. Well, if there's no points in that group, you're not going to get a surface. Okay, and then you can rebuild the surface. And that should just about do it. Oops, why am I not getting a surface now? There it is, there's the surface. And then you can just go and tidy up the boundary. So I'm going to edit, delete line, anything outside the boundary. So these 3 lines, that's the true edge of the subdivision. I know there's a line here, shouldn't be there. All of these lines in the corner here shouldn't be there. And if you go to the turning circle here, these lines here should be gone. And now you have a true perimeter of the data. If you don't remove those triangles, you're going to get a volume calculated there, which is going to skew your actual results. Okay, team, does that answer your question, I hope? Was the problem the point group being empty? Okay, yeah, that's just a typical problem. So just because you create the point group, you know, it has to have something in it. So I always check, and it's very easy to check. If you look here, like I said, this black dot appears. If there's no black dot, it means it's empty. And if you click on any one of these, you should see the list of points inside the group. If this is blank, if it's an empty group, then you're using an empty box to build a surface. Okay, I'm going to delete that. So how do we put in the water main? Well, the water main, according to the Town of Richmond Hill standard, and let's look at that. So if we go to Seneca Highway, not highways, CDA module 2. If we go to the earthworks, sorry, the engineering and public works document, you'll see here that the water main, let's look at the water main document. So water main, it's going to tell us here the design criteria. I just want to know the depth. So the depth of water main when it comes to the pipe is, oops, it's in this. This is how you calculate it. Line valve base water. Where's the water? Depth, minimum cover. So here we go. Minimum cover shall be 1.7. So from the finished ground down to the top of the water main needs to be at least 1.7. Okay. So that's what I'm going to use as a guide. So here's how we do it in AutoCAD. Okay. So this is the procedure. The first thing we do, I need to create a layer. It's not already there. So in here, there should be a layer called C. C proposed, not storm structure, not, so here it is, C water pipe, right? And you might want to create a new one, copy, paste, this is the profile. Water main. Oops, profile of the water main. I'm going to make that current, and I'm going to use a cyan. So here's how we do it. So if we want to be below the ground, I'm going to trace my design. So I'm going to draw a polyline from the finished ground to the road. I'm just tracing the design with a polyline. Okay, and I'm going to stop right there. That's the edge of asphalt. So if you remember this grid, this profile property, the view style, has a graph that has a 5 times vertical exaggerated. So every dimension vertically, you have to multiply 5 times. Horizontally, it's 1 meter is 1 meter. Vertically, 1 meter is 5 meters. So if I want this to have cover of 1.7, I want to go straight down 1.7 times 5. You can actually use AutoCAD as a calculator. If you type in cal, enter, gets a calculator. So 1.7 times 5. So I'm going to make a copy or move this. I'm going to move this 8.5 meters. I'm going to pick a point anywhere on screen, turn my ortho on, and I'm going to go straight down 8.5, which represents 1.7 vertically exaggerated 5 times. So there's the top of the water main in general. Then if the water main is a 150 millimeter pipe, I believe that's the minimum pipe size. If we go back here, yeah, diameter, I'm going to use a 150 millimeter pipe. Okay, that's typically the smallest pipe size, and on a cul-de-sac, that's probably typical. So 150, calculate 0.15 meters times 7 is 105. So I'm going to make a copy of this, straight down again, 1.05. And there's the bottom of the water main. So now I have the top and the bottom of the water main in very crude terms. Okay. Now remember, this is AutoCAD, right? If I move this, everything related to Civil 3D moves, but not the AutoCAD stuff you're drawing. Okay, so just keep that in mind. So now that I have all this, you have to remember, if you remember the design of the water main, remember this return. Somewhere in here, there's a PVC pipe of 150, but the loop is a copper pipe. So let's take a look at that standard again. Remember we had to draw this. Remember we had to draw this. So now I'm going to look at the details of this a little bit more, right? So from where the return is, from here, 4 meters, 1.5 meters, and then 3 meters is where the reducer is, right? This is called the reducer, right? So we go from a 150 pipe to a 50 millimeter pipe. So from this intersection, we're going to go 4 plus 1.5 is 5.5 plus 3 is 8.5. That's where the reducer goes, 8.5 meters. So let me get rid of the grading. Temporarily, get rid of the grading in the wall we don't need. Oops. And we can get rid of this too. Yeah. So from here, we want to go 8.5. 8.5. So that's where the reducer is. I'm going to put a point there. There's a point. Okay. So that's where the reducer is. So the pipe on this side is a 150, and then beyond this point on this side is a copper pipe of 50 millimeters. So, and then in the profile, remember we're drawing on this alignment. In the profile, the water main ends right here. So I'm going to put a point right here. That's the end of the water main. So I'm going to project those 2 points. Here's a skill we had from before. Project points to the profile view. This is where the PVC ends, and this is where the water main ends altogether. So I'm going to draw those here. Say, okay, I'm going to, it doesn't matter what the elevation is, so I'm going to bring them into range. It's the station I'm interested in. So I'm going to just allow them to be finished ground, existing, right? It's the station I'm interested in, not the elevation. Okay, whoops, 0 is off. That's why that's happening, because I turned the surface off. Never freeze or turn 0 off, my mistake. Okay, so here's everything. And it looks like there's another layer that wants to show the finished ground. Okay, there we are. So now I know where the water main goes from PVC to 50 millimeter copper. Okay, so to draw that, I want to do this. I'm going to trim this off here. Actually, I got to draw a line. That's a label. I can't do a label. So I'm going to draw a line from this node straight up. I'm going to draw a line from this node straight up, and then I can get rid of the points, right? Because it's the station I'm interested in, not the elevation, right? So here's where the water main ends, and here's where the water main changes size. So I'm gonna trim top and bottom here, and then I'm gonna make a copy of this from the end point to the midpoint, trim it off on this side, and trim it off on this side. So there's the center of the pipe in profile. And if it's a 50 millimeter pipe, I'm going to go up 25 millimeters and down 25 millimeters. So I'm going to calculate again. Calculate 0.25 meters, 25 millimeters, times 5 meters, times 5 vertical exaggeration. So 0.125. So I'm going to make a copy of this. 0.125. Oops. 0.125. And then down 0.125, and there's the copper water main. And that's the reducer, right? It goes from one size to another. Now, if you want to draw it like in the plan view and make it look a little more realistic, what you can do is just draw a line kind of from here to here, and the midpoint of that will be on the mark. And here, say, and extend to here, trim to here. And then I'm going to mirror that. Put this over here. Maybe just draw a vertical line from here to here, and from here to here. Intersection here, and intersection here. And then you can kind of trim both pipes. And get rid of that. So that's the reducer, right? You may want to keep this position. That's the exact moment where it happens. So that's the center of that item. So it reduces. When you get to the end, what's it going to look like? Well, it's going to look curved, right? Because we're looking at the end of the pipe. So what I do here is I draw an ellipse. So I'm going to offset horizontally half of a pipe diameter. I'm hung up now. I hope I don't crash. Okay. So then what I'm going to do is I'm going to take half the diameter, right? That's the, whoops, 0.5. So calculate 0.025 divided by 2. So 0.125. So I'm going to offset 0.0125. So there's the width of the pipe horizontally, and there's the top of the pipe vertically, 5 times exaggerated. And then here we can use an ellipse. So this is the center, right, the end of the pipe here. So I'm going to draw an ellipse, which is a circle stretched vertically. So I'm going to go from the intersection here to the intersection here, perpendicular to the width, and that's what it would look like in profile. So now I can get rid of all these construction lines and trim it here. And if you want, you could even trim it here. Right? But I like to leave it because here you would actually be looking at the cross section. Think about the plan view. If you go back to the plan view, on this alignment, you actually see the cross section of the pipe. Right? So up to here, you see the profile, the edge of the pipe, right? The side of the pipe. And then when you get to here, you actually see the cross section. So I would leave that like that, right? So there's the piece that comes back. And then this piece actually comes back over here. Watch. In the plan view, right? This is the 150 pipe. If we go back to the standard, right? This 150 copper pipe comes all the way to this valve and this T, right? So right up until here, this is a 150 all the way to the T. And I guess technically there should be a reducer here, right? Because it reduces from the T, I believe, is a 150 by 150 with a reducer coming. So it looks like that's missing. That's a detail for construction, but I think it's generally understood. I don't think you can get a T that reduces from 150 to a 50. Although you might, I'm not sure. So where does that happen? Well, I want to now project a point here. Find this position in the drawing on the profile. Find it here. And it should be just over here somewhere. Elevation from existing is fine. And there it is. So now I can draw a line from here just to find that position. I can get rid of the point. It's the station I'm interested in. So what's happening here? Well, I'm going to make a copy of this. A copy of this ellipse. And bring it into here and trim this from top to bottom. And then this should be dead center midpoint. That's where the T is. And that's behind the pipe, right? Depending on how you're looking at the pipe, right? If I'm looking from this side, right, then this piece of the water main is behind this PVC pipe, right? So everything behind the water main should be, hidden, so we can show it as a hidden line if you're talking about real drafting, right? So then I can make a copy of, I'm going to draw that back center. Just want to do this so I have a reference point. Extend here, and then trim it. And then I want to make a copy of this from the intersection to the top of this and to the bottom of this. And then I can trim it here. Don't need this anymore. And then this actually goes all the way to here. And all of this would be hidden lines behind the PVC pipe. So we could make this hidden. Technically, right? It would be behind that pipe, right? So that's the water main to a certain extent. There's other things to draw, but that's how you can draw the water main. What do we do here? Well, we have to connect to the existing water main. So if we go to here, where's the existing water main? Well, it's this position right here. This is the existing water main. This is the proposed water main. Sorry, that's the edge of pavement. Oh, I think the year I did this, we didn't have the water main. So if this was the water main, the existing water main, I'd like to know where that is in the profile, right? So again, I'd put a point there. Project that point. Oops, project that point. This one here. Put it here. Again, make sure the elevation is in range. That's where the water main is. And then the size of the pipe, I think, was a 300. If you look at the topo I gave you, the size of the water main is a 300. So we want to draw an ellipse with a 300 diameter, right? And I'm going to assume it's below the center line of road by 1.7, but I have to multiply that by 5. So I'm going to scale it by 5. There's the top of the water main here. And across here, that's the top of the water main. Make a copy of that straight down. 0.3 times 5, which is 1.5. There's the bottom of the water main, and then I can offset it half of 0.3, 0.15. I don't need to exaggerate that in the horizontal. And then I can draw the ellipse. So that's the existing water main. At the correct depth, at the correct position, with the correct size. Did I do that right? Calculate 0.3 times 5. 1 point, yeah. And then we can just take the water main across to connect to it. Yep. Trim it here. And this could be existing, and there's your proposed, and there's your entire water main through it. Right? That's how you draw the water main in profile. That's just the pipe. Then there's all the other stuff. You have to show all your hydrant locations. There is one here, right? There is one here related to this standard. So the hydrant would be from the T 4 meters plus 1.5 meters. So the first hydrant would be from here, 4 plus 1.5 is 5.5. So there would be a hydrant right here. Point. So that's the hydrant position. Now it's not going to be right on the pipe, right? It's going to be somewhere in the cross section. So where would it be in the cross section? We have to go back to the standard for roads. Go back to transportation, and we look at the cross section for the road. Remember this? All right, so we were using R2, right? The symmetrical 20-meter right-of-way. So the hydrant is from the street line 3.3 meters from the street line. That's the center of the hydrant. So if I'm going to offset 3.3, take this and go perpendicular, that's where the actual hydrant position will be in section, right? But it's projected to the same station in the center line. Right? So if I was drawing the hydrant, that's where it would be, right? But I didn't change the station, I just moved it in section. So we do this again. This is where the hydrant goes. We can draw that position here. Again, bring it into range. And that's where the hydrant grows. So I'm going to draw a line from the node straight up, get rid of the point. I just need the station location. And that's where the hydrant would be. So then I would draw, it depends on the symbols. I'm not sure how they do it in Richmond Hill. Let's take a look. I think I have a drawing from Richmond Hill. I should have one. Should have one from OSET. So here's what a plan profile looks like in Richmond Hill. We looked at this before. So how do they draw the hydrant? Whoops. So they just use a couple of lines. It's very thick, right? One thick line coming up with H and V. That's how you draw a hydrant in the profile. Right? And you can see the water main, this hatched thing. So go back to the drawing. So I'm just gonna, the pipe is typically a 150, right? So I'm gonna calculate 0.15 divided by 2. It's 0.075, so I'm gonna offset 0.075 to this side and to this side. So that's the thickness of the pipe coming up to the surface. And then we trim it to the top of pipe. And then we put in dtext H and V, whoops, H and V, and we would probably change the style, oops, change the style to something prettier than that, so not Arial, but I'm going to use L80 with a height of 1 so that it appears to be 2 millimeters on paper, and that's the hydrant. And then if you want to hatch it and so on, okay, and you try and make it look like this. So next semester, you'll have sample drawings of what the drafting should look like, right? This is an example of Richmond Hill. The project we're doing next semester is actually in Milton, so it'll look a little different. But you can see, you know, the minimum 1.7, right? It's straight down, right? A cover of 1.7 meters, right? And then vertically exaggerated 5 times. Okay, so again, that's not everything, but that's most of what what we're going to do next semester for sure. And then if you want to hatch it, that's another story. I'm going to isolate the pipe information, and BH for hatch. And then you could hatch it by touching it if it was a closed thing, or you could pick a point. As long as the drafting is clean, if you're inside, it should hatch. If you're inside, it should hatch. And then you might show that unhatched or not, it depends how you want to do it. The holes I would show unhatched. I wouldn't hatch that, and I probably wouldn't hatch this at this end. I'd leave that open, and I'd leave this open as well as a cross-section pipe. And then make it color color 8. Oops, color 8. If I turn everything on, it starts to look a lot like that one we were just looking at. Right? And then if everything is here with the pipes and so on, then you have to, again, you have to deal with, you know, if you're looking at this one, you know, you have storm and sanitary pipes. The water main pipe is always above storm and san. Remember, this cover here is almost 3 meters. The pipe for the water main is going to be somewhere in between. And you'll see the water main. And then you have to label it. And then there'll be others, right? There's a hydrant laid out every so many meters. There's a valve chamber that needs to be put in. There's a valve box that needs to be put in. All the details of laying out the water main we're going to cover next semester. All I'm showcasing today, right now, is the CAD skills. And these are AutoCAD. I'm not using the only Civil 3D tool I'm using is projecting a position and plan to profile, which is something I know you already know how to do because we did that for the design of the road profile. Does the water main have to be parallel to the edge? Yeah, it's a trace of the finished ground. to begin with. Now, it may have to change, right? Like if there's a conflict, if two pipes are like crossing and they're touching, you may have to lower the water main or raise the sewer. You might have to look at conflicts, okay? But that's a separate issue. That's a design consideration. I'm just showing you how to draft it in general. Okay, I know I'm going fast. I don't expect you to learn this today. I'm going to teach this all again next semester. I don't think I can because I haven't used it in years. I'm not sure if I can use it, if I can actually, I don't know enough about it to teach it effectively. Is that the proper answer? I've never used it. I've never used it. If you want to learn how to do that, I would explore it. I certainly wouldn't discount that as a skill, but I don't know enough about it to teach it. I've never used it at work, to be honest with you. I'm sure I could figure it out, but it's more complicated than just the pipe, because when you're dealing with a pressure pipe system, you're not just drawing the pipe, you have to draw all the bends and all the details. It's almost like what we do in the civil world is a certain level of drafting. When you draw that the water main or a pressure pipe using the pipe net with a pipe or the pressure pipe system, it's almost a mechanical drafting detail. So the level of detail is very different from what we do in civil. And again, if you are designing like a pressure, sometimes sanitary pipe is under pressure, they actually pump it, or water main that's being pumped. If you're dealing with transmission lines, like these large pipes that service an entire city or a portion of a city, then the network pipe, the pressure pipe system is probably the way to go. Or if you're designing a pipeline across Ontario or Canada, that might be the tool to use, right? But the focus of this is the local sewers and sanitary systems. So and in my experience, in my career, I've never done those transmission sanitary and water main pipes or gas pipes. So I've never used it. So I really can't speak to it, Trung. I hate to admit. But I'm sure it's not difficult, though. I'm sure that it's an extension of the kind of stuff we've been doing. So gravity sewers is kind of where my expertise is. And then the pressure pipe, the water main, the local, it's drawn typically this. And the different consulting firms that I worked with and for subdivision work, this is the kind of preferred method, AutoCAD drafting only. Okay, and that's all I'm going to expect you to be able to do. Okay, you could do a pressure pipe this way as well, right? But then you may want to use the pressure network. You can actually do flow analysis using Civil 3D pipe networks with a storm sanitary water main. You can put in the flow in each pipe. And again, in my experience, sanitary and storm flow using AutoCAD to design the size and the slope you need is more trouble than it's worth. So we typically use an Excel spreadsheet, and that's how I'm going to teach it next semester as well. I know you used one in MPT. We're going to use one as well. So we're going to go from the hydraulic design using a spreadsheet, and then the geometry design using Civil 3D to draw the pipe. And then it'll be a little bit of back and forth. Like in the drawing, if you have to make a pipe steeper, then you have to go change the slope on the spreadsheet to match and make sure that if you make it steeper, maybe you can make it smaller. If you make it smaller, then you can go and change the drawing and make the pipe smaller, and vice versa, right? Or if you flatten the pipe, it might have to get bigger. So next semester, it's convenient if you're doing this type of design production work, it's convenient to have two screens where your drawing is on one screen and your spreadsheet is on another, so you can look at both at the same time. On a computer, I'm using a laptop, there's only one screen. On a computer with one screen, you may have to toggle back and forth, or you may have to split your screen to see both at the same time. But in a production environment, if you were doing design, the preferred thing to have is two screens, so that you can look at your spreadsheet and your drawing at the same time. So if you change the geometry, you can check the hydraulics. And if you change the hydraulics, you can update the geometry, right? So if you change the slope on the spreadsheet and the pipe size changes, then you have to go and update the size and the slope in the drawing. If you change the slope in the drawing because you have to, go underneath or above another pipe or a structure, then you have to go and update the slope on the spreadsheet and see if the pipe needs to be adjusted, right? So if you make something steeper, you might be able to make the pipe smaller. If you make it flatter, you might have to make it bigger. And that's the bit of back and forth. The way it was described to me when I first started design, and it's not just pipe design, but municipal design in general, One of my mentors used to say this all the time. It's an iterative process, right? You kind of do something and then revisit something else and then go back to the first thing and then see what effect it has on the other thing. It's kind of like juggling Jello. You're back and forth. It's iterative, right? You go through the design and then you review it and you review it, and it's kind of a cyclical process, right? Because the road design is going to dictate where your pipes go, and then where your pipes go is going to dictate where your road needs to be, and the road is going to influence your grading, and the grade influence how deep your pipe needs to be. So it's all interconnected. You have to start somewhere, right? But as you go through the process, you might find you have to revisit something you did prior so that everything works together. So it's iterative, right? You kind of revisit everything on an ongoing basis. And the difference between me and you right now is I iterate less because I have more experience. So the more experience you have, the more work you do, the more projects you work on, you'll find that you're going to zero in on the solution a lot sooner, right? So when you're novice and new, it might take more iterations, right? But it's always an iterative process. Even for someone with my experience, it still takes time to go through it, 2, 3, 4, 5, 10 times, depending on how complicated or big the project is. And then the paradox is it's an iterative process, and you want to iterate once, which is almost impossible. You can certainly reduce the number of cycles and iterations, but you can't eliminate it. You can't just design it once and for all and be done. There's always something that you need to revisit. Even if you don't change it, you have to go back and review. Okay, so what I've done so far, does that still work with my previous kind of assumptions and design? Okay, good. So keep going. Oh, okay, now I've affected this. And if to make this work, I have to change my road profile. Or to make this pipe work, I have to change the lot grading. So then you have to go back and revisit some previous design and so on. So that's the kind of nature of the game, and it's going to be a little bit of back and forth, right? Update your grading. Oh, now my pipes aren't working. So update the pipes. So now my grading has been affected, and back and forth and back and forth. So there is a process, and I think we followed it as much as possible. But in a real world environment, you'll find you're going to go through the process, and then you'll have to kind of go through it again based on, oh, there's a little hiccup here. I gotta rethink this. Oh, that's going to have an effect on what I've done up to date. So I got to go back and make sure this matches now, right? Because if I change my road profile design, it changes my front lot corner, it changes my grading. If I change my grading, I might lose cover on a pipe, right? If I lower the profile of the road, it's going to change my grading. And if I change the grading, now I might compromise cover. I have to lower my pipe, right? If I raise my pipe, I might have to raise the road. If I raise the road, it's going to affect my grading. I got to do my lot grading again in that area where the road got higher, and so on. So it's always interconnected like this. And the sooner you see that interconnectivity, the better you'll be as a designer. Because when you make a change, you have to make sure that if that has an effect on other parts of your design, you have to go and update everything to match. And that takes a while to get used to. Okay, and you'll get a little flavor of that next semester for sure. Because you're going to follow a process, and you'll get to a point where, oh, now here's a problem. To solve it, I have to go back and redo something I did before. And then you'll go through the process again and say, oh, okay, here's another issue. Okay, to fix this, I have to go back to this previous step and update some stuff over here, and so on. So you'll get a little bit of that experience next semester, but it's all interconnected. There's a solution. There's no answer, and if somebody's designing the same location, they're going to have a very similar solution, but the details will depend on, what kind of approach you take. Okay, because I'm going to give you the concept again next semester, but the details that you provide are going to be similar to everybody else, but it'll be your own thing. So you might do something a little bit different, right? Even though it's different, it's in a sense generally the same solution. Okay, any other questions? That's as far as I want to go. I don't want to go too deep. There's a lot more I can show you, and I will do next semester. Drawing the driveways, drawing the service connections, all kinds of stuff. So if you haven't finished assignment 6, please do so. It's due Friday at lunchtime, not midnight, lunchtime. If you've already submitted it, fine, you could double check it. You could submit it as many times as you like. Remember, I only look at the last one. Right? So if there's an issue, if there's a problem, make sure you submit both drawings though, right? Your DWG base plan and your PDF grading plan, right? So if one of them changes, always submit both at the same time. Otherwise, I'll only see one. So if there's no questions about assignment 6, that's all I had for today. just a little bit of a preview. Less than half the class is attending today, so I'm assuming most of those other folks who aren't here have already submitted, and they're busy getting ready for other things. Do you have a test today or tomorrow coming up still, most of you? I'm related to Sylvia, but do you have any advice for job searching during the 1 month break? Yeah, Steve, if Friday and today, yeah. Stephen, if you're looking for work, like I said, I suggest you start applying in January, February at the latest. If you're interested in municipal design work, there are many, many consulting firms that do have, even in the GTA, there's a lot of jobs in the GTA, a lot of companies in the GTA. A lot of the companies that I've dealt with in my career are situated in Markham, like Highway 7-ish and Woodbine, in and around there. There's a lot of firms that do just municipal design, and then there's some of the bigger companies that do a little bit of everything. They do architecture, they do municipal, they do structural, they do all kinds of engineering, civil engineering projects, geotechnical. Some of them have their own survey departments and so on. So it depends kind of how you want to focus your career. I will give you this as an advice. If you work for a large firm, you're going to be very specific in the type of job you do. So you'll get hired as a drafting person or a CAD operator or a designer or a field inspector. They're very, very defined roles. If you work for a much smaller firm, you may have more opportunity to do a little bit of everything. So you might be doing inspection, you might be doing drafting, design, and you might get exposure to a wider variety of things in a smaller firm, simply because there's not enough people to, have a full-time job in any one area. So there's that to consider, right? So in a big company, you'll have a very focused kind of scope, and in a smaller, and what I mean small firm, I mean less than 50 people, right? A new company, small. There you'll have an opportunity to do a little bit of everything. I was fortunate in my career. I started with a company. There was about 45 people in the company I started with. And I got hired as a CAD drafting person. I got into intermediate and senior drafting. I spent 2 summers doing inspection, and in between I was doing more drafting, and then I got involved in design, some project coordination. I did a little more inspection, and then I started to focus my career on detailed design. I stayed away from management because it was not something I wanted to do, but that opportunity did happen for me. They offered me a project management role, which I decided not to pursue. But I was able to do just about everything except sign my own drawings. I'm not an engineer, but I did everything but. So it really depends on what type of work you want to do. So I would look for jobs in municipal design, CAD operator, junior inspector. There's a lot of entry-level jobs, and there's I don't know if you're registered, but Seneca College has a thing called Seneca Works. I don't know if you've ever seen it. Let me show that to you. So if you go to the Seneca Works webpage, so if you just go here, sorry, let me make sure you can see what I'm doing. So if you go to what's called Seneca Works, sorry, it's all one word. So Seneca Works is not co-op, but where is it? Yeah, this is its employer. So Seneca, okay, if you're new to Seneca's free online, more here. So if you go to Seneca Works, oh shoot. So this is for employers, but you can actually view the database. So this is for employers to post jobs, but as a student, you can register for the job bank. So employers will post to this. I can't remember how you sign up as a student. Returning to Cinewigs. Okay, this is the employer page. So we don't want employers, we want students. Why can't I find it? Academic. I don't know why I can't find it. There it is. I have to go through Google. Okay, this is the page. So if you go to Seneca Works, you can log in as a student. Okay, I'm not a student. You can log in as a student, so you can create an account, and then you can see all the jobs that are posted through Seneca. So employers come to Seneca and actually register. So Seneca actually does some research on the companies, make sure they're not, they're a legitimate firm that's, a professional firm, not just some fly-by-night company. So they're vetted a little bit by the college, and then they actually post jobs, and they actually pick specific programs that they're looking for students to graduate from. So if a civil firm or a consulting firm looking for civil graduates comes here, they'll post the job, and they'll only make it available for those in the civil engineering department, technicians or technologists. So they're very focused. So if there are jobs for civil graduates, you'll see them here because they target the program. Okay, so that's a really good resource. So if you're looking for work, that's a great place to start. So try the Seneca Works. The Seneca Works. Why is this not working? You might have to look at it through the careers. I don't know why it's not working. So as a student. Yeah, I'm not a student, but anyway, you can if it's not working, you might have to contact either IT or the Career Center. It does describe all this. Yeah, is that it? Yeah, that's the page. And you can create an account as a student and then have access to those jobs and employers and so on. Yeah, thanks for that, Stephen. So that's a good place to start, right? And like I said, the companies that are looking for graduates focus their attention on students per program. So if a company is looking for civil graduates, then civil students, because you're associated with that program, will see those postings. So you can kind of do a custom search for jobs that are relative to your program. Yeah, so that's something worth doing it during the break, looking around, right? And then you'll see company names. And then the companies might post. They might post jobs, and if they don't, you'll at least know their names, and maybe you can look at their websites directly to see what they're about and what they do, so you can learn more about the companies. Usually, they provide their webpage through the Seneca Works site, but not always. Okay, so that's it for today. That's the end of the course. Don't forget to submit your assignment by Friday at lunch, and I'll see you next semester. Good luck with the rest of your assignments and tests. Like I said, if you did assignment 6 on the weekend, then I know you wouldn't be worried about this class right now. So you should be studying for your other courses or doing other assignments.